Hi, my name is Lisa Richter. I'm Director of Industry Outreach and Growth for CSIA. Welcome to the Masterclass. Before we get started, a quick word about CSIA. Probably most of you here today are familiar with the association, but if you're not, all you really need to know is that CSI's mission is to help SIs build better businesses. How do we do that? Well, for starters, we have a team of volunteer SIs who have crowdsourced a best practices manual to help SIs scale their businesses. CSI also offers a certification program and many other resources and benefits, including professional development, learning from your peers, and access to professional services experts, including insurance, financial, and legal, who understand the unique business needs of SIs. For partner members, CSA offers an ecosystem to grow their SI partner programs and understand their customers' pain points, monitor industry trends, and share their thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps SIs, industry suppliers, and manufacturers connect and do business. For SIs and partners, it provides a platform to nurture your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. If you are not currently a member, now is a great time to join. Membership provides you and your entire team a full lineup of virtual events and other resources, from accounting to sales to operations, 365 days a year. Plus, being a CSI member means you get special pricing for the CSI Executive Conference in addition to other resources. If you are currently a member, thank you. I hope to see you in New Orleans next month. Oosh. One last housekeeping note before I turn it over to today's speaker. If you have any questions during the presentation, please use the Q&A feature in Zoom versus the chat. That helps us keep organized. The session is being recorded, and you will get a link to the recording in the next day or so. At this time, I would like to turn it over to today's speaker. Ravi, take it away.
Thank you, Lisa. I appreciate it. Let me get the screens up. I hope you are able to see my screen, Lisa, Holly.
Yep, you're all good.
Okay, great. Thank you, everybody, for joining us for this session. I hope it will be worth your while. Modular control systems in classified areas, or hazardous areas, as we would call it in different parts of the world. And I will just give you a brief agenda, share a little bit of Stahl, what exactly we do, set the agenda for the discussion is what are the end users expecting, some first steps that have been taken, and what do you do with the modular automation with the remote as a remote IO and a modular automation with Stahl's IS1 extended IO. And then, of course, some references to test beds and construction examples. That's me, been about 14 plus years with Stahl in multiple countries, Middle East, and then now in US. We presented Stahl in many of the organizations, the Foundation Field Bus, the PCIC, the Profinet, Profibus Middle East organization, and now here in Houston, the Open Process Automation. That's my email ID, and that's the email ID for the US colleagues here in case you're looking for any support. Briefly on Stahl, we are headquartered in Germany. We get into electrical and automation products for hazardous areas. We do provide trainings into hazardous areas and some services, and then definitely a very high reliable products out over there and solutions which ensure your safety in a classified areas. For those of us who are working globally, we have agents, we have subsidiaries who are able to support you locally in the area over there. That's a whole range of portfolio: electrical junction boxes, control systems and distribution boards, lighting, cable entries, plug-in sockets, and then of course the automation portfolio of interfaces, monitoring systems, and cameras. Okay, so what are the end users asking us? What are the end users specifically in the process industries asking us? They want us to reduce their cost, and they want help to reduce cost in their capex cost when they build projects, when they do their greenfield projects. They want to reduce their time to implement a project from an idea and convert it into production, into sales. And where the major challenge is converting this idea into production. This is where they want to reduce, and that is how they will save money and be able to turn around their investment quickly. Flexible manufacturing assets. You have the pharma industry as a great example. Suddenly they were up and running, setting up COVID-based vaccine manufacturing plants, and of course, turning around the existing plants to be ready to manufacture those vaccines. So in today's dynamic world, you need your assets, your plant to be flexible enough to be used in any applications down the way. Reduce operation cost of their assets during the life cycle. Could be obsolescence, could be maintenance issues, could be related to upgrading systems, and then they want to ensure that those costs are low. Transfer data across the automation pyramid, very important with the Industry 4 requirements popping up, where everybody wants to generate the maximum cash value out of their existing assets by optimizing their processes. So this becomes very critical. And of course, using the best-in-class equipment without the proprietary systems limitations to optimize those processes. So with these asks that we have from the customers, what can we do? We have the situation of some histories to look back on, to build upon. As far as the modular construction industry is concerned, this has been going on from the World War II. I read some instances where you had prefabricated constructions or prefabricated buildings being put together and being able to deploy them in the war zones or even otherwise in the armament factories. So that was the first experience of pre-constructed, prefabricated buildings, and that was related to buildings at the first, but it was caught on by the other industries quite quickly. There is an article from American Chemistry Council on their Chemical and Engineering News, which talks about in 1979 of how the chemical industry has adopted modular construction. Going far back, it also means what are we doing now? 2009, the European Union focused on trying to grow their business globally, and they led investment with Invite to define and develop use cases for a flexible, fast, and future-proof modular production technology. That was a country level or a region level initiative. They recognized that modular construction would make a big difference. Later on in 2013, NAMUR, which is an international organization related to end users who are using process automation, they set up in 2013 and set up the requirements on what should be the requirements of automation for the modularization of process plants, and they emphasize right from construction all the way to the life cycle. In 2018, the Open Group came together where they wanted to ensure that from the life cycle perspective, from the perspective of having an open, interoperable control systems, they are using the best-in-class components and are not tied down to a proprietary system. The latest standard, the 2.1 is available, and even the adoption guide for the complete ecosystem is available on their website. Modular automation. What is modular automation, and especially if these process skills are related to hazardous areas? They are all having their control systems on the skid, as you can see here. So we are going to have all the electronics or control systems incorporated on the skids, which reduces a lot of the field side wiring. You're not running field device wiring all the way to the control system. So that is a very economical way to put together. Besides, of course, a lot of advantages of modular systems which come into play. And I will not go into this at this moment in this presentation. Some examples of how we are going to do it. explosion-proof panels. My guys would not be happy that I'm talking about modular automation, and they're going to not sell these explosion-proof enclosures, these big ones, where you can see the standard industrial-grade electrical products, automation products being packed into an EXD or an EX explosion-proof enclosure. Of course, you can see the IS1 or the Zone 1 HMI or the Zone 1 remote IO also in a standard NEMA 4X or an EXA enclosure. Or what would be the other protection methods? It would be a purge. This would be a typical purge solutions where you put everything you have from a complete assembly of a panel into a single one and then provide a purge either through regular air or through an inert gas, as they would call it, and implement a purge solution which is sitting next to the skid or on the skid in a hazardous area. Is this all really a good optimized solutions? No, we definitely know the challenges of working with purge, a very very high utility cost over there, a lot of challenges when doing maintenance and operations, and definitely similarly the challenges of using an explosion-proof enclosure. Even a screwdriver running off this side or the door wall could create a gap where you could allow explosive gases to go inside that enclosure and the protection is no more valid. So a lot of care needs to be done to be implementing these kind of solutions. What do we do? Definitely one element is to use our IOs over a network using the standard, I wouldn't call them open, but they are open enough. The Profibus DP, Profinet, Ethernet IP, or Modbus TCP IP. With those interfaces, you could run them to the SCADA, HMI, or to the control platform sitting in the control room or in the safe area. We are assuming here these are working as IOs and the controls are all based on the DCS system or a centralized PLC system. What do we do when we go here? What are these remote IOs opportunities available here? Multiple certificates, including country certificates, heavy-duty shipbuilding industries, especially the FLNG carriers, the offshore platforms, or even the FPSOs. We are ready and certified. How do they look? Or how are they built together? A simple DIN rail, a bus rail, and you can plonk this socket here for the CPU and power supply, and all the IO modules. You can see the older versions over here, and you will realize the IOs are physically, the form fit factor backward compatible. Even if I want to remove this old Profibus DP base and the CPU, I will have no challenges doing that because I will just use this new socket, a new CPU and power supply connected on that. I can still use the same enclosure, same IO, same terminations, and then of course put in a new GSD file over there, and I'm ready to go with the migration project. So this would be the remote IO as what we see the older generation here and the newer generation. Some opportunities with the newer generation, CPU redundancies, power supply redundancies, or even a complete system redundancy. The caveat is that this is all dependent on the control system and the protocols. So you need to be careful when you are committing to that. Reach out to us and we can share with you what is possible from a redundancy perspective. Definitely, as I shared earlier, all the multiple protocols over there which are available, and a very important point. In the older versions, you would ask for a Modbus TCP IP, and Murphy's Law, I would not have it in stock. I will tell you, can you use Profinet? Learnings from that, better electronics now being available, we now have a diff switch on the base, and I can switch any of the protocols I want. No limitations for you as a system integrator. If you would like to stock up, yes, you have a supply chain issues going on. So maybe stocking up is a viable one, but definitely just in time is a good option, but then you can still select the protocol depending on the control system or the PLC you're using. And yes, it is tested with most of all the control systems. It is tested for HART interfaces or for plant asset management. It is ready or will be ready soon for FDI, which is coming up from the Fielcom group for all of the FDI hosts. Otherwise, the FTT frames from all of them are ready. So you could use an FTT frame from Yokogawa, from Endershauser, or even Packware, and then still be able to access the hard data from the analog modules, because those analog modules are hard transparent. Some of the IO modules, definitely, as you can see with the blue terminals, intrinsically safe. These are 4 or 8 channel, only digital output, digital input output, basically configurable, soft configurable. I can configure them as input or output, but in pairs. So it can be 10+6, 8+6, depending on how do I want to configure. Analog, universal, or configurable hard IO modules, or analog input modules, or not even analog input, it's analog input and output. I can configure them as input and output, single channel, 4 to 20 or a 0 to 20. Then, of course, the temperature input modules, RTDs or thermocouple, again 8 channel. This is a unique digital output module, which has got solenoid valve built into it. And then, of course, sometimes we need high power. We can have a solution for that as well. The good option with this is that we do have the DO outputs, the 4 or 8 channel, which are only used for typically for driving solenoid valves, which are available in the industry. Or if you need a DO module with a valve built into it, you could use our DOMV module, which takes you away from building a separate valve island and a separate remote IO station. These were good for zone 1 div 1, and then we have the zone 2 div 2 as well. And here you can see the non-IS versions also. Definitely, we use non-incentive in US and North America, and then in Europe and all, we use the EXE. Oh, that's my automation in the room. The light switch went off because I was not moving around. So sorry about that. And this is the hard analog 8 channels, the same soft configurable digital inputs, and non-incentive or EXE inputs as we would use in the ATEX ICX world. All other options are similar to the zone 1 div 1. The key features: multifunction IO signal, as I said, configurable input output, a very theoretical calculation of lifetime for 15 years. Previously with the electronics, it used to be only 10 years. Because they are field mounted, we are now having a better range of temperature from -40 F to about 165 F or 75 degrees C. This gives us a very good capabilities to put them in the field without a need of a heater or any kind of a cooling system. Additional status information. Oh, I'm going to put my hardware in these extreme conditions. But if these extreme conditions are running over a longer period of time during the exposure in the field, maybe my electronics lifetime could be affected. So we do have an internal intelligence, if you may, or an artificial intelligence. I love to use that word that we are implementing this, that it can calculate how much of your lifetime out of the calculated 15 years is being exposed to extreme temperatures, and that could affect your lifetime in the field. And it would give you probably a year before that it is going to break down. Hey, I'm going to be breaking down in the 13th year. This is the 12th year. Be ready to migrate or move on to the newer module. Now, essentially, that is not required. I have customers who are using the older modules for about 20-25 years, and they say, Ravi, I don't need to migrate. And then since you have a form fit factor, backward compatibility. When they break down, I can replace them. So same situation, you are now aware, you can buy the spares and be ready. And then when the replacement or the breakdown takes place, you can change them. Or if you would like to be proactive, you can definitely replace them. Enhanced diagnostics, line fault detection. If I have a field side cable break or a short circuit, I would get an alarm into my configuration tool, into my asset manager. This could be useful during operations when you are doing a lot of maintenance work in the plant, or could be even useful when you are setting up and commissioning the system. Your control systems are still not in place, but you could configure the IOs and you could check all the cabling in the field. Downward compatible is that what I was talking about, both as a form fit factor as well as software compatibility. And then because it is multi-channel, it is configurable, you don't have to worry on the cost part. It is very, very competitive. That's the digital output module I talked about with the bucket valves. And I will show you some construction pictures later. There are about 8 of them, and basically having intrinsic safety if you're using them in a dim one, obviously. And these are the 3x2 ways sonoring valves. For the non-IS signals, for the zone 2 div 2, we can even provide you a redundancy of the IOs. This could be because of some critical applications you have and unmanned platforms, for example, or you need single node integrity. And the good part is we have the redundancy requirement handled, or the voting taking place on the IS1 station itself. It doesn't need to go to the control system for a decision that which data do you want to take, which module failed, the primary or the backup, and which one do you want to take the data from. So this is handled at the CPU. So very much reduces the communication load and improves the response time in case of these failures. I talked about the non-IS or the incentive IOs modules and the IO field devices. Can I put them in a single control panel? Yes, I can. My colleagues love to call these as elephant ears. And how does it get implemented? We all know that IS and non-IS, we need to keep a 50 mm gap. My R&D team was smart enough. They said, you don't need to physically move them away. We have to have an air gap of 50 mm. So any sparks from the non-IS side doesn't impact the IS side. And by 50 mm, the spark energy is deteriorated by that time. So with this elephant here, definitely in a single control panel in the field, I can have IS and non-IS signals. Only thing is you need to ensure is that when they go out into the control box, into the cable entries, they are separated. And then when they are in the cable tray, they are separated. So this is important that you need to be careful about. What do we do with the IOs? I talked about those line fault detections. We talked about the proactive predictive maintenance. We have LEDs which indicate to you. We provide you a blue LED here, which gives you that am I going to die off before my lifetime? And if it is, it kicks up as an alarm 12 months before the potential breakdown. And then, as I mentioned earlier, you can always reset it in your alarm manager, and the plant continues to run. There's no shutdown. It is just an alert to you that, hey, I need to be aware that this could be a potential problem. And then, of course, we have the web server built in. And then is also a similar FTT frame when you are doing asset management, or we are trying to configure it. We can configure the individual IS1 station, configure the individual analog input output, set the heart variables, and you can also see the complete configuration of the 16 modules here for the zone 1, zone 2, and see if they are configured or not configured. So as I mentioned earlier, when you have you are into a project installation and commissioning, even before your control system in place, you can do these configurations and you are ready when the control system is up and running. Just plug in the Profinets or set up the Profinet addresses or Ethernet IP addresses, and they should start working. Okay, that was the remote IOs. What about the future? We talked about the demand of what the end users are talking about, what they want to see in the future. Are we ready? Is Stahl ready for it? Yes, Stahl is ready. Stahl wants to be part of your journey into the future as part of using the new automation technologies available. Here, you saw the old network which I talked about, and here I've removed all those protocols. So what happens now? How am I going to be communicating? Where is the control system going to reside? What are we doing down the way? So bear with me. I will share what exactly are we doing now. The first option. The remote IOs that we have are currently available with the OPC UA server built in. So what does that help me with? Well, there is one standard, and there are a lot of brownfield applications where customers say, I don't want to do a major change. I want to only focus on trying to get data out into my cloud or into my third-party in-premise softwares or applications, which will allow me to optimize the plan. So either my new segment I'm adding to the plant, I should be taking care of. So you can use the IS1+. Or if I'm having an IO migration plan, my proprietary system is not having that OPC UA interface, I can use the IS1+. You can see there are two Ethernet ports. I have one running to the control system. This is just an example of the brand and not specific. And then I have the second port, which goes to a switch, and then it can take the data to the cloud and QTT and everything else, or it can go onto the in-premise software apps that you have. So you can implement OPC UA under the NAMUR Open Architecture. This is the NAMUR Open Architecture concept, which says I don't want to disturb the major part. I don't want to do a major changeover or a migration, but when I have an opportunity, add-on in the plant or IO or any kind of a migration, I would like to implement and have raw data access of the IOs to the cloud or to my software. So this is one application which you can do, and just some slide shots here using the UA expert, how you can see the IO data, the values, the data types, the timestamps, and of course the good or bad status code coming through the UA expert software. These can be, as you know, OPC UA is transparent, so you can be implementing this in any OPC UA compliant software applications. So the remote IO is typically acting as a data server to you and just pushing data up to the field or to your in-premises software, which you can use to optimize your plan. Next, what are we doing? We have these new versions, and just briefly, 61131. I'm sure you all will know it is the software standard. It covers all the 5 programming standards for a PLC. All the major vendors who do control systems use 1131 as a standard, but then they are customizing it. And when they customize it, it brings in limitation from a portability perspective. So that is one of the open process automation forum requirement, portability and interoperability. So taking that forward, especially from the perspective that we would expect the end users to use these new technologies in the hazardous areas. And Stahl has been very, very clear they would like to support the end users in their efforts to optimize their plants. We are able to provide them these options of these runtimes. So we have the Codices runtime, 1131 runtime available on our hardware with the -0, the -20, from Schneider or Universal Automation. This is a 1499. The 1499 also includes the 1131, so the programming of the control system still remains the same, but it incorporates the concept of distributed IOs, which would be more similar to an architecture which is incorporated in distributed control systems. The Straton runtime from COPA-DATA, and then of course the -40, which is an open system with a Linux. And then if you want to embed any software into it, we can collaborate with you. You sign an NDA, and then we can load any softwares which you would like to implement in your project if you would like to do that. The standard OPC UA multi-protocol is only available with 128 megabytes, but for the newer codices, Universal Automation, COPA-DATA, or the extended IOs are available with a 256 megabytes. And then the newer technology of modular automation, the standards being built by NAMUR, we can implement it with all of these people, with all of these hardwares, with all of these softwares. These softwares have the capabilities to generate the MTP file, which can then be read by the higher level control systems, and they can then pull in that data, and then they can read the equipment which is there, the IS1+, and then all the HMI screens coming up, the alarms and everything else that comes together with an MTP file. Here's a typical example, and I have given an example using codices, but it is applicable for Universal Automation, it is applicable for Straton, for COPA-DATA. I have the codices runtime here. It's a compute plus IO. I have the codices web visual with our HMI built in, maybe a class 1 division 2, maybe a class 1 division 1 or zone 1, zone 2. They're all put in a standard NAMUR 4X or EXA enclosure. And then there are, of course, you need a development environment. You have the IDE over here. And then, of course, there's the HMI, the asset manager, and the alarm manager, the complete control network that is available to you. This in a NAMUR 4X is sitting on your SKID as a complete solution, and it is a local control system for you, a local modular automation system. So that is our vision from the perspective that we will be able to have a local control station on the SKID with an open communication or a transparent communication or a communication with a standard information model talking to a higher level SCADA or a control system. Just a screenshot as an example. Here you can see the Stahl ARM Cortex, that's the CPU we use. It's Linux based, and then you can load it in the development environment and generate the control applications, which you can download into the IS1+, build the screens on the IDE as well, and then using another tool, you can generate the MTP file also. So that's basically what you can do with codices. Something similar with COPA-DATA. You can do everything same as what you have with codices. You can do it with COPA-DATA, and they have their own MTP-GENERATOR, which is built in with Straton, and they have a separate MTP suite, which you can then combine it with the SCADA software and visualize all that is going on in your plant, on your SKIDS. Similar situation with Universal Automation with IC 61499. Just a configuration tool from the Enterprise Automation Expert, which is what is available right now with Schneider, which is one of the promoters. We are the co-founders as well of Universal Automation, which will be an open platform based on 1499, and you can access the IS1+ as a library. It is already available, and you can generate the MTP files also. We talked about open process automation forum. We talked about what customers are looking for, where they are expecting to use a open, interoperable, portable softwares which are hardware-wise vendor agnostic. So we can use the extended I/O. The open process automation uses either the OPC UA for communication, uses the EcoRT, or shouldn't say a brand name there, a 1499 standard or a 1131 standard to communicate with an advanced control platform sitting over here. So we fit in over there. We are ready to support our end users to be able to provide them the solution if they want to implement the open process automation standard. You can do it using a OPC US server. You can alternatively use the 1131, currently the Codices, Straton, or the 1499, the UAO or Universal Automation EcoRT runtime. Basically, this will run on your SKID, which is a process equipment assembly, and then your advanced control platform here has a process orchestration layer, which is what the MTP is all about, and both Open Process Automation and the NAMUR MTP working group are jointly setting up the information models and standards so that this is in conjunction together when they're implementing these projects. So that is where we sit from Stahl's perspective to be able to support our end users going forward for the new technologies. We're talking a lot about new technologies, but are they available right now? Yes. With ExxonMobil using Yokogawa's OPA server, and I have put it under the umbrella of OPAF because the 1131, the 16499, they all come under OPAF and OPC UA. So bear with me to share this information with this umbrella. Yokogawa's OPA server testbed. So it's a testbed over there where we have participated. And then now we are participating on the field trial of about 2000 plus IOs over there. With Saudi Aramco, with the EcoRT, again, a testbed over there, Georgia Pacific, and EcoRT of Schneider, with Siemens PLCs and Rockwell PLCs. Also, a lot of the other control system vendors are in place over there. COPA is the coalition of process automation or open process automation vendors. So there is a solution in place for COPA. COPA is promoting open process automation. COPA is promoting or supporting end users who want to build test beds, who want to learn quickly, who want to go through a training schedules. So that is where Stahl is putting and supporting it with our hardware solutions over there. And COPA has been able to implement one test bed or a training support center with Equinor. With the OPA server there, Petronas is doing it with Yokogawa OPA server. Reliance, which is right now in the purchasing mode, is doing also with the OPA server also over there. So a lot of this is in the purchasing mode right now, but all of these are already implemented and are working. So yes, to a certain extent, the standards are being developed, but to a lot of extent, they are also available for implementation at your first stages. So if your end users are ready, if your OEM machine builders are ready, we can support them to implement these for your projects. Some example of constructions. This is very important from the perspective of hazardous areas. Not unlike your safe area control systems, that it needs to be very carefully constructed or built. And as you would all know, these have to be certified. So when you need certifications for ATEX, ICX, when your OEM or skid builder is exporting to the other part of the world, or if they're using it locally in the US, we can support them with ETL certificates to build the complete panel over there. So this product certificates or an assembly certificate can be part of our offering to you so that we can build it together, give you a certificate, and you're not spending the money calling a third-party inspection agency. So that's just an offering. We are happy to sell you components and we are not interested in building cabinets. Basically, it became a kind of a market demand for us because we do work with a lot of oil field services companies who want triple certifications because they want to deploy hardware in any part of the world. And then we had to build assemblies based on that. We don't get into the software part, we just help build these and certify the assemblies. What you are seeing here is a Zone 1 Div 1, the older version, definitely. This is the one having the 24-volt DC in a conduit, the socket here, the fiber optics, the power supply, the IS modules here, and then the DOMV modules, which I mentioned, which have got valves together. All of these constructions, as you can see, is a NAMUR 4X. It's not purged, it's not explosion proof. So I can build this panel, certify it, and you can deploy it in any part of the world. This is another sample, a construction where instead of the combination of IOs and DOMV, we have all the IO modules built in, and then the customer wanted even the 24-volt DC power supply to be provided locally. So this can be a redundant power supply or a simplex power supply, and then you can build all this construction. Just as an example, compared to a single channel density field solution, we can do in a 760 by 760 anywhere between 64 to 128 signals, depending on analog or digital. So anywhere in between would be your average density for a field panel in a Zone 1 to 1 with the current or the older CPU models. This is a Zone 2 Div 2 solution, 1200 by 1000, some different applications here, anywhere between 128 to 256 signals, depending on analog or digital. You can see some of the sample constructions here. Here, the customer doesn't allow, or the end user doesn't allow the field technicians to work on the IO module. So these are pre-wired to the field terminals. Some circuit breakers, some redundant power supplies, some 4-wire isolators for 4-wire signals, and you can see this construction here. This is a good construction as an example between IS and non-IS. You can see the blue terminals here and the black, and you can run them into the control field, into the field separated out over there. So a very good example here on the IS, non-IS together. And this is the one application with the IS together. And here you see we had a larger electrical switch, power disconnect switch, which we put into the explosion-proof enclosure housed inside a NAMUR 4X. These kind of solutions are where we have our expertise with hazardous area, and we ensure that we take care of all the requirements of assembling a hazardous area panel, and we get you the certificates for that. We talked about the brownfield opportunities where we end up with customers wanting to implement a NOAA, or we want to implement a migration for just the IOs. A very good application here as an example with IES. I don't need a IO panel. I don't need an isolator panel. I don't need to power them separately. I don't need a marshalling termination panel. I can have a 2.2 by basically 2 meter by 800 by 800 panel with front and back. I can have, and you can see the purple wire, which is a Profibus DP here as an example. I have these 4 columns of IO modules with barriers built in it, and then only the terminations at the back. From 480 analog to 960 digital signals, depending on the combination you are working with in your application. So this is a very good example where you want to create an open system, where something what open process automation says, I want to disconnect the IO from the controller. I want to disconnect the controller from the software, and I want to disconnect the controller from the other softwares, the HMIs, the process optimization software, the alarm manager. They want to use the best in class. As an example, look at your Android phone compared to an Apple. The Android phone with their marketplace, you are able to use multiple applications from multiple vendors for whatever way you want to use your mobile phone. your Android phone particularly. So that's a simplified analogy over there. And I am coming to my close of 45 minutes over there. So I believe this would be my last slide. So this is something again for the process skills as an example. So these are just examples what we build. So I would like you to ignore all the brands which are in place. So here is a Siemens CPU particularly, but it could be any PLC CPU with a power supply and all that in an EXP box with a NEMA 4X enclosure for the remote I/O. So if I have the Stahl's extended I/O, I wouldn't need this explosion-proof enclosure. I would be just having my software embedded over here, and then I could be doing a control algorithm and transferring data over OPC UA or over the OPC UA with runtimes built in from codices or extended or OPAF or from EcoRT or from Strato. So that is all that I have for you. I hope I was in time, Lisa.
You did great. I do have a couple questions, and forgive me if you've already answered this in the presentation because
Sure.
a lot of this stuff goes right over my head, but let's give it a go.
Yeah.
In the OPC UA version, is the interface two ways?
No, it is a diode. It's a one-way interface. So I am able to ensure that nobody off premises or even nobody is able to change any parameters in the I/O. So the diode is acting as a data flow going out, not coming in. So that ensures cybersecurity, that ensures nobody is modifying the control parameters in the system.
Another question I have for you is, for the extended I/O, will we embed the runtimes when we offer the IS1 Plus?
Oh, yeah. Yeah, these are the model numbers over here. So you would get the licenses when you order with these model numbers. They will come preloaded, and you only have to take the development environment from those respective vendors, and you are good to go.
Great. Holly's got a few slides for me to pop back up, but in the meantime, Rob, if you want to pop your, if you can, pop your email address into the chat. If anybody wants to contact you directly, they can do that.
Yeah.
If you're not able to do that, or no big deal. Okay, so here are my last slides. On behalf of CSIA, I would like to thank our speaker, Ravi, for this informative discussion. And I would also like to thank our Stahl for sponsoring this event. And of course, thank you for attending. Be sure to bookmark the CSIA events calendar so you don't miss any upcoming events. And that's a wrap. Once again, thank you for joining us and have a great day.
Thank you, Lisa. Thank you, everybody, for joining us on this show.